Thanks for the kind intro, Marcel. Absolutely, it's an honor for me to be here today, and I'm going to be telling you about my passion, which I developed during my PhD at EPFL. But I'm very much aware I'm not anymore in the echo chamber of AI in Silicon Valley, so I'm not going to take for granted that everyone knows what Replit is. So let's start, from the onset. Let me tell you what Replit is. It's a software creation platform built over 3 key pillars. The first one is cloud. Then we have AI and collaboration at the core. The reason why we made this choice is because software development has always been painful. And I know many of you here in this room have written code in your life, so you know exactly what I'm talking about. So we are trying to streamline that experience by bringing everything on the cloud. So Replit is a website. You log in there, and you get everything that you need for the software development lifecycle. Then you have an AI companion and several AI features that help you to be more productive. And last but not least, we have collaboration as a first-class citizen so that you can work in parallel with your colleagues and with your friends. Now, our company mission is adhere to software fast. And the example you see here is probably like the most important demo that we built last year. I like to call it our quintessential example. What's going on is we have one of our software engineers literally speaking software into existence. So they're using the mobile app from Replit. They are speaking a prompt. So we have a speech-to-text engine going on. We translate it into a prompt. That prompt then goes to our family of LLMs. We create the code under the hood. We test it. We deploy the web application. And after a minute, it's up and running. And here, the request was to build a very simple workout recorder application. Now, of course, this is not the most advanced piece of software you've ever seen in your life, but it's really telling the fact that we could do this in 2023. You can only imagine what we're going to be capable of doing in the years to follow. So this is the reason why we embark into this journey. And it has been very exciting to the extent that we reach a place where we have more than 30 million users today. So a lot of people have learned how to write code on Replit, but today they're building companies on Replit. Today they are creating professional software there. And more than 300 million projects have been created up to date there. And the one interesting insight that I always like to mention is the fact that on a daily basis, 200 million tokens of code are being generated by Replit AI. So we reach a stage where a lot of productivity is not only driven by humans, but is also driven by our AI features. And as you can imagine, this number is only bound to grow. But you might ask me, we have been writing software for decades. Why do we need yet another platform where to make it happen? Why aren't we happy with Visual Studio and GitHub and everything else is out there? Well, I would argue that software is likely the most advanced artifact that mankind has ever produced. As of today, we estimate that 3 trillion lines of code have been written over more than 200 programming languages. And as a matter of fact, companies, they reinvest more than 10% of their revenue on average on anything related to the software development lifecycle. So it's by no means a cheap endeavor. It's very complicated not only to create, but also to maintain software. And the other stat also proves that more than 35% of the developer time goes on non-coding tasks. Trivial stuff that no one really enjoys, but you have to go through in order to ship a feature, in order to sell a product. So let's keep in mind the statistics, and let's dive into another one, which I also find very telling. Out of the 8 billion people that we have in the world today, and roughly 5 billion of them have access to the internet, only a tiny amount is capable of developing code. We're talking roughly about 30 million people. That translates to 0.3% of the global population, which is in charge of not only sustaining, but also expanding our digital future. So you can imagine that when you see that number, it becomes almost like a moral imperative to try to increase it. Not only to fight, of course, the inequality due to that, but also because as myself, I'm a relatively optimistic person when it comes to technology. I would love to see the number, of course, to grow and then empower more people, which in turn, they will really boost the creativity that we have as mankind. Why isn't this happening today? Well, building software is freaking painful. And I'm sure if you've done it and you go through this list of like feedback and comments, most of them will resonate with you. Say you are with a colleague, you're using Git, there's a merge conflict, good luck with that. It's going to take you quite a bit of time to solve it. Or you build a tool, it runs flawlessly on Linux, you move it on Mac, it doesn't work. Again, a lot of trivial work that hinders your creativity, but that you have to do in order to ship whatever you have in mind. So we want to remove all these barriers. And as a field, we've been waiting decades for something to happen, like to enable people not to go through this painful list of ordeals. And don't get me wrong, in the last few decades, the progress of how we create software has been it's been absolutely amazing. A lot of it has happened also here at EPFL, a lot of amazing new programming languages. Back in the days, we wrote software on punch cards. Then C and assembly look like magic. And if you look back at them today, compared to the environment that we are using in the present, of course, they look very dated and absolutely non-productive. So that growth, I would argue, is super linear, but it's definitely non-exponential. We're missing that inflection point that is going to make the difference. Well, it turns out that I strongly believe, and several other people in the field believe, that the inflection point is here, and of course, it's AI. Now, for those of you who love quotes, back in 2011, Mark Andreessen, one of the most notable VC investors in the Valley, said that software is eating the world. No one could really argue with that. At this point, software has penetrated really every vertical, every kind of domain that you can think of. But then just 6 years later, Jensen from NVIDIA kicked in and said, sure thing, software is eating the world, but AI is going to hit software. If you look back in the days, this code is pretty amazing. That's exactly when I started to get passionate about this field, so applications of AI to source code. And if you ask me back then, where would we be in 2024, I would have not been able to predict what we're capable of doing today with AI. And I tend to be a quite optimistic person when it comes to technology. Otherwise, I would have not gone through a PhD and done research in my life. So the acceleration that we've experienced in the last few years is absolutely amazing. And we expect that to go even faster. So for that reason, one of our missions at Replit now it has become to create what we call the 1000x developer. I'm sure you heard of this concept of the 10x developer, like a person who joins a company or a project and all in a sudden they make it 10x better just because they were able to tackle a very hard challenge or because they have amazing insights that no one else has. Well, if you take these capable individuals now and you put in their hands AIs and agents and a lot of different features that allow them to try different solutions in parallel, and in a sense, have a fleet of interns at their disposal that actually they are AIs, these people will become even more productive. So I call this a vertical expansion. Like we want to make every single developer more capable. But then, at the same time, we started to witness also a different type of expansion, which I'm going to call the horizontal expansion. Let me bring here one of my favorite examples. So this is Priya. We met Priya last summer. She was attending a hackathon in San Francisco. And Priya was a program manager at Microsoft. So very little coding background. She joined the hackathon, opened Replit, and in 24 hours, she built an application end-to-end. She went from an idea, which I found amazing. She took very boring lecture notes, turned them into multimedia content so that it would be much nicer to learn from that. And she made that happen all in a span of 24 hours on Replit. So Priya, to me, represents what we are being capable of doing today in terms of lowering the barriers of entry to writing code. And I'm very proud to say that she left her job, she decided to start a company with one of her former colleagues, and they're building their new startup on Replit just today. So this horizontal expansion is literally empowering the next billion software developers in the world. This is what we aim to do at Replit. You heard me now talking quite a bit about how AI could be impactful. And I promise you we're going to be doing a deep dive on what actually we offer at Replit. But before that, let's take a step back. Let's see what is the impact of AI for code across the entirety of the industry. So I pick a study from Gartner, and their predictions are that by 2025, 80% of the development lifecycle will use generative AI. Now, pay attention to what I said. I'm not claiming that 80% of the software lifecycle will be replaced by Gen AI. I actually don't believe that. I don't think we're all going to lose our job next year. It's rather a lot of these steps are going to be enhanced by Gen AI. A lot of the tedious factors are going to be gone. And in parallel, of course, we're also seeing a sizable reduction in terms of time it takes to write code. These numbers are only bound to grow over time. As a matter of fact, when in front of these statistics and looking at the growth of our product, we realized we need to show that we have high conviction in terms of how AI is going to impact software development. We cannot give those features only to our paid members. Otherwise, the long tail of our free tier users will never learn how to work in tandem with AI. They will never learn how to be productive with the new tools and with the new features that we have available. So we made a very bold bet. And back in October, we announced AI for all. And this was a very risky launch. It was probably the most thrilling, exciting thing I've ever led in my life. We went from a very relatively small amount of traffic to this crazy spike here. So since October and until this is end of January, we already had 2.5 million unique users leveraging Replit AI. And I bet that by now this number is above 3 million as of today. And we did it because we want everyone to have access to the same level of capabilities and be empowered by AI. Now, as you can imagine, in a past life, I was at Google. Launching something that requires like a 100x workload spike overnight is relatively uneventful. It's something that, as a large company, you're trained to do, and you have all the infrastructure to make that happen. This was very scary for a startup, but we came out unscathed. I'm very proud of that. So as of today, you can log in on Replit right now, and you get the full power of AI. It's about time I show you what we actually have on the platform. So this is how Replit looks like. On the left, you have a file tree and a set of different tools, which will look very familiar to you if you've ever written code. Now, in the middle, you have your editor, and you can already notice that right now the user here is not writing code. They're actually expressing in natural language what they want to do. Here, I'm asking to replace my logging library with something else. And on the right pane, our chat pane that allows you to communicate with our internal AI, we now give you the proposal on how you can modify your code. We explain why that modification is going to happen, et cetera, et cetera. So this is just one glimpse, but I just wanted to give an idea that we have a full integrated experience so that you don't have to jump between different tabs and open different tools. It's a one-shop stop, and you can get everything you need here. Let's go quickly through a list now of features. First one is we have AI-powered code completion. For those of you who use GitHub Copilot, this is going to look very familiar. There is one key difference. We optimized for latency. And I'm going to explain a bit more in detail about the models. But if you look at the animation, you will see that most of the completions are happening in a very short amount of time. We strive to have our P95 latency around 250 milliseconds, which is on the border of what is perceived as almost instantaneous for humans. Like, in a sense, you believe that the model is reading your mind and generating the code that you were about to type. We did that because it gives a completely different developer experience compared to something like Copilot or ChatGPT that requires several different seconds to generate code on your behalf. How did we make this happen? We went all in. We trained our own bespoke code LLMs. We did the first release of this back in April. We have an updated version that we released in October. It's a small model. It's a 3 billion parameter model. It's mostly trained on code from scratch. And every time we release it, it was state-of-the-art in the class size, so with comparable size models. You can use it today. These models are on Hugging Face. We release them under a commercially viable license. We have friends and startups that are using this model to build products, that people that built local alternatives to GitHub Copilot that are running on their laptops. So it's there for you to use, supports 30 different languages. And this has been like the key reasons why we could do that AI for all launch that I just explained before. By using a smaller model, specialized on a single task, we're able to have better unit economics and open this to our 30+ million users. Some other features, as you remember, we have these inline actions from the initial screenshots. There is a variety of them. You can generate code, you can modify it on the fly, you can debug, you can explain, et cetera, et cetera. The reason why we built this kind of UI is because our main goal is to allow developers to stay in the flow. So you don't stay in the flow when you jump to another chat panel and you ask exactly what you want to do. You are in your editor, and you trigger the AI to do some modifications straight into the code. So we have a set of features that you will find on your contextual menu. Speaking of, sometimes you don't just need the code that is in your editor to generate or to transform. You also want to bring in relevant code, say dependencies, libraries, sometimes even external documentation. So under the hood, Replit AI is building what we call a smart context by means of retrieval augmented generation, of course, but also by means of the fact that we have a full overview of the platform where we're running. So we know every time that you run code, we can see your execution traces. We know which libraries you imported because we take care of dependency management for you. So this gives us an edge in terms of how well we can build the context for the LLM. Now, I'm going to give you a glimpse of what we just released or we're about to release. So you get some sneak previews today. The first one, which I like very much, is AI in the shell. I've been using the shell, I think, for 30 years at this point. I don't want to disclose my age, but it has always been a relatively painful experience. You forget commands, you forget flags, and then you get lost on Stack Exchange or Google in the hope of finding exactly what you're looking for. So one of our engineers integrated AI straight in our embedded shell. You ask in English, list the top processes by CPU usage. The model generates the command, and we're good to go. So this is the kind of integration that I get very excited about because it removes a lot of the tediousness in the process. Last thing is, we are going to ship an AI multimodal interface where, say you're brainstorming with a colleague, you're on a whiteboard, you're deciding the schema for your database. You snap a picture of that, you upload it on Replit AI, we translate that into SQL code that we are going to apply directly into our Replit database. So this is the kind of low-friction interaction that we're trying to build, once again, to make you as productive as we can. If you connect, though, all the dots that I've been talking about, you will realize that Replit is becoming almost the first native OS operating system for generative AI. So at the epicenter, we have our family of different models. Some are our own, bespoke trained. Some others are third-party models. And we built a connective tissue around them. We built these AI services that allow to take different data and information from, say, the file system, as I was mentioning before, when we build the smart context, or directly from the shell, or directly from the code execution environment, all the way to the user input, of course, right? So we have an editor where you can type code. You can speak code into existence, as I showed you at the beginning. You can upload images. So in a sense, we are building a scaffolding around those models that allow you to interact with any different modality. And the reason why I very much pushed us and my team to go in this direction is because when you think of the system in the way that I just described, all in a sudden, an amazing data set emerges. And this data set is composed by all the actions that developers do on Replit. And I can tell you for a fact that by means of scale and diversity of the action types that we have on the platform, I believe this to be one of the most valuable data sets in the world today. As a comparison, on the left you will see the Stack V2, which is an amazing data set released by Hugging Face. They go through all the process of collecting public repositories from GitHub, issues, data from archive, data from Wikipedia, et cetera, et cetera. The entirety of this amazing effort accounts for a bit more than 60 terabytes. In turn, Replit generates 3 terabytes of coding data every single day. So in less than 2 months, basically, we could build something as large. And the data types we collect are all the way from run outputs to the single keystrokes and clicks you do on the editor. So we have data structure that helps us to really unravel how code is born from the first keystroke until you deploy your application. Of course, we keep track if code has been generated by an AI versus humans. And we collect a lot of diagnostics from static analyzers and so forth. So very rich, very diverse, and it's something that's going to allow us to train models that we haven't seen yet. So the way for me to rationalize this data and figure out how can we build something on top of it has been to redefine our company name. So probably for those of you this sounded familiar, but Replit stands for REPL, so read, eval, print, loop. This is the first tool you ever see when you start to write code. It's a command line that allows you to basically write a snippet of code and evaluate it on the fly. So the initial mission of Replit was to bring a REPL on your browser. So the easiest way basically to access a REPL that you will ever find. Now, AI kicked in, and I had to figure out how can we rethink the concept of REPL now that we have a much more powerful tool in our hands. So I came up with this pun. Instead of AGI, I called it ADI, Artificial Developer Intelligence. Don't get me wrong, I'm very grateful that there are a lot of smart people working on AGI, not only on the technical side, but also on the safety side. But I wanted Replit to be laser focused on building the most powerful AI for developers. So the way I thought about it is, okay, the first step is reflecting. So devising what is the execution plan, generating the code, figuring out which code to run, which external tools to invoke, etc. Then the moment you have this plan, you actually evaluate it, you execute it. And the outcome is binary. It either runs correctly and it aligns with the intent of the user, or it fails. In case of failure, what you do is you percolate, so you distill all the different useful data that this failure has generated. Execution traces, debug symbols, user actions, and so forth. And you funnel all this data back into the ADI model, and you learn how to make it more powerful. Now, I understand that this is very abstract and, of course, very ambitious. So, if you promise me that we're going to keep this private to this crowd today, I'm going to give a sneak peek of what I'm going to be talking about in public next week. So we have a new model type built exactly on this concept. Let's go to an example. It's going to make this easier to understand. This is how Replit looks today. Whenever you have an error, so one of these squiggly lines that is generated by our diagnostics, you can hover on the squiggly line, click the debug button, and what we do is we build the context automatically, as I mentioned before, and we ask the model to generate the fix for you. This works spectacularly well for most of the trivial problems, as you can imagine, and our users love this feature. If you notice, though, it took quite a bit of time. Like every time you click end-to-end, reading the answer, deciding which snippet you want to adopt, bring it back to your code base, it takes roughly 30 seconds. Remember, my mission is I want to make sure that you stay in the flow, that you don't waste any time. How can we make that happen? So the insight here is every single day, we have hundreds of millions diagnostic events happening on Replit. 10% of them are deterministically repairable. So some of those errors that you saw before, right away, the LSP, the static analyzer, can fix them for you on the fly. For the remaining portion, 60% of them, like any power law phenomena, are due to just 20 common diagnostics, such as syntax errors, reference missing, indexing, indentation, and so forth. And then there is, as always, a long tail, the 30% of the remaining events, which are due to more than 370 diagnostics, which are usually hard to repair. So now we're going to target just the remaining 60%. You can imagine that if we do a pretty good job there, instead of fixing your errors 1 out of 10 times, we're going to be able to do that maybe like 2 out of 3 times, which is amazing. We're going to save you a lot of time, especially considering that this happens hundreds of millions of times per day on our editors. So what we build is the first low-latency code repair AI agent. And it shouldn't come as a surprise that Replit is what in the Valley is considered a GPU-poor company. We're not a big tech company, so every time we build AI, we are under the constraints of latency and cost. And latency because of we want to provide a better user experience, right? So we wanted to go from those 30 seconds that I showed you before to something that is almost instantaneous. And cost because we will love to put this in front of every single user. So a fixed point in our design then becomes the size of the model. So we did a supervised fine-tuning pipeline on a single-digit billion large language model, which is at least 2 orders of magnitude smaller than the model we saw in the previous video. There we're using GPT-4 Turbo. I don't know which rumor to believe, but it's likely above 1 trillion parameters. So the model that we're using in our agent is much smaller. We use 2 insights here to make it work. The first one is we built an advanced data pipeline that combines real-world errors and diagnostics coming from Replit and synthetically generated repairs. Then we take a generic code LLM and we turn it into a tool. So we make sure that rather than expecting a natural language input or code, now our bespoke model is taking basically a method signature that includes also the LSP error message. I'm aware I'm in front of a lot of academics and researchers today, so no talks will be whole without showing a benchmark, right? So let's go through some numbers. These are the code repair performance that we experience. On the left, you see a list of different models that we tried. We start from this DeepSeek Coder 7B as our baseline. Then we try the latest and greatest from both OpenAI and Anthropic. And at the bottom, of course, you find our solution. The LeetCode benchmark is based on LeetCode submissions. LeetCode is a platform where you go to train to pass coding interviews. And as you can see, we have regardless of the fact that we are at least 2 orders of magnitude smaller than all the other models, we still retain a certain advantage across all of them, which personally I was already extremely excited about. But then, perhaps coming from personal experience, benchmark data rarely reflects the distribution of what happens in the real world. So we tapped into our own gold mine, right? We have Replit, we have a ton of data. We built our own benchmark based on the errors that our users make in the code. It turns out that this is much harder. But still, our model comes out with an even wider gap compared to the largest models out there. And the result is this kind of user experience. Here I'm collaborating with one of my colleagues. You see our 2 cursors, and every time a squiggly line appears, so there is a diagnostic, we just show you a diff in line. If it's correct, you apply it, and you're good to go. So we went from 30 seconds to a sub-second developer experience. I'm not going to have time to show you the last thing that I was planning, so I hope I managed to get excited about AI for coding, and I wish you will join us in our journey at Replit. Go ahead, create an account, and I'm happy to take questions later. Thank you.
All right, Michele, that was great. Let's briefly sit down. We don't have a whole lot of time, but just 1 or 2 questions, and the more comfortable, the better. So one of the questions I think that is on everybody's mind, because the tool that you are showing is so impressive, and I remember right when Replit was repl.it, and you could sort of log into the browser and run a bit of Python code. And now you have this sort of all-in-one system that's extremely powerful, and you are building this tool that basically takes more and more off the load, right, from the programmer. So where is this going, right? So we have some of these questions here, right? Let's say, okay, I am teaching, right, computer science. I see more and more students. Depending on that, isn't that dangerous that to some extent they don't learn? I mean, of course, I guess one of the answers will be, well, there's learning, but then there's, of course, 99.9% is just actually working, and that's probably what you're working on. But how do you see this going? Where in 5 years, right? So the earliest image that you showed, or basically I'm just talking to the thing and it does the rest for me. Is that the ultimate end goal here?
I don't think so. I think it's going to take us longer, and I don't want to sound pessimistic. The reason is there is a certain level of creativity in humans that you can't easily reproduce with AI today. I think that is equivalent to achieving AGI. If we do in the next few years, then I'm going to be proven wrong. Yeah. But if the timeline is more dilated, then humans will still play a key role in devising software. As an example, I don't think AI in the short term will ever come up with a new framework or a new library. That is the kind of creativity that you need as an experienced software developer to realize I need a new layer of abstraction in order to make my life easier.
Yeah.
GPT-4 is not going to come up with that, most likely. So yes, it is dangerous not to learn and rely completely on generated code.
Yeah.
I will argue that it's not that different compared to what people were doing in the past, copy-pasting from Stack Overflow or like IRC, where people were passing each other snippets of code. In a sense, we need to teach students the method, not programming languages or specific lines of code. Yeah.
Speaking of students, so you yourself, you did a PhD here, then you were also at Stanford, then at Google, and now at Replit. So you have also sort of these two hearts. I mean, on the one hand, you're a researcher. On the other hand, you have to ship products, and you do it very rapidly. So how do you bring those two roles together? Can you, or is it just, sorry, I have to ship, and your researcher heart just has to bleed? How do you deal with this?
I think there's always a lot of tension, and I hope I'm not turning into Dr. Jekyll and Mr. Hyde in the process. So I always wear different hats. But I also find it exciting, to be fair. The data set I was mentioning before wouldn't happen if we didn't have a product that people loved. So we all know that the most important currency in AI is data. So in a sense, I feel motivated to ship, because we're going to get better data. And we're going to also understand from the users if they like or they hate what we're building. So this is a feedback loop that I was missing partially in academia, maybe completely missing in larger companies. And like a startup brings you as close as you can to the users, which makes it super thrilling.
And just a very short but important last question, because everybody is asking it, right? Are you using Replit to build Replit?
Of course. We have a project internally called Replit on Replit, and you can spin up Replit on a repo.
Excellent.
It's very meta.
Well, everything else would have been surprising.
Yeah.
Thank you so much for coming and for giving this
course.
fantastic talk. Thank you.
Thank you, Michele.